Moving at 67 kilometers per second, a 6-kilometer wide block of ancient ice and rock is tearing through the vacuum of deep space. This object has been falling toward our sun for millions of years. It originated in the Oort Cloud, a vast spherical shell of icy debris that surrounds the outermost edges of our solar system. Astronomers designated it C/2023 A3, better known as Tsuchinshan-ATLAS. It is currently running a cosmic gauntlet. The harsh reality of our solar system is that most comets on this trajectory do not survive the inbound journey. Simply witnessing this comet from Earth requires it to survive a path where most others fail, establishing the high stakes of its multi-million-year journey. The physics of a solar approach are violently destructive. As a comet gets closer, intense solar radiation rapidly bakes the ice, causing violent outgassing. Simultaneously, immense gravitational tidal forces pull at the porous nucleus, threatening to rip the entire structure apart. We see this happen frequently. Recently, the highly anticipated Comet Atlas S1 crumbled and vaporized completely before it ever reached a point where we could easily view it from Earth. Early in its approach, researchers analyzed the trajectory and physical properties of Tsuchinshan-ATLAS. Multiple scientific papers predicted it would suffer the exact same fate and disintegrate long before putting on a show. Yet, it held together. The central mystery for astronomers became clear. How did a fragile 6-kilometer block of ancient ice beat the cosmic odds and survive? In early 2023, two separate facilities spotted a very faint object. It was detected by the Purple Mountain Observatory in China and independently picked up by the Atlas Early Warning System in South Africa. This image shows the early observation panels of the comet. By tracing archival images backward, astronomers found a distinct, faint coma structure already forming when the object was 9.1 astronomical units away from the Sun. 1 astronomical unit is the distance from the Earth to the Sun, meaning this comet was active while still out past the orbit of Jupiter. At that extreme distance, water ice cannot vaporize. Instead, the activity was driven by a rare mechanism, the phase transition of amorphous to crystalline ice. Amorphous ice lacks a defined crystal structure, and as it slowly warms in deep space, it reorganizes into crystals, releasing trapped gases in the process. This surprisingly early, steady dust shedding indicated a highly durable and unique internal structure, allowing it to vent pressure without breaking apart. As the comet crosses into the inner solar system, the environmental conditions escalate. Temperatures spike, and the rocky ice begins to heavily bake. The heat triggers extreme mass loss. The nucleus was shedding 170 kilograms of dust into space every single second. Spectrometer data captured during this phase revealed a chemical anomaly. The comet is severely depleted of carbon. Instead, its spectrum is dominated by unusual sodium D lines, which are specific wavelengths of yellow light emitted by glowing sodium atoms. In total, the comet lost 10 billion kilograms of mass. The uneven venting caused severe rotational instability, but the 5.9-kilometer nucleus held together. If you enjoy learning how the universe's most ancient objects survive the brutal forces of space, take a second to like this video and subscribe to the channel. On September 27, 2024, it reached perihelion, its closest, deadliest approach to the Sun. It survived the intense heat and gravity and slingshotted back outward toward Earth. Surviving the fiery crucible of perihelion allowed Tsuchinshan-ATLAS to emerge on the other side as a global visual event. As the comet approached Earth in October 2024, it burst into the evening sky. It became an easy, naked-eye object for millions of people. This image shows the comet's striking anatomy. The brilliant white dust tail is a direct result of that heavy, 170 kilogram per second shedding before reaching the Sun. Running alongside is the glowing blue ion tail, created by charged particles interacting with the solar wind. Earth's orbital perspective also created a bizarre anti-tail. This is a rare optical illusion where larger dust particles left behind in the comet's orbital plane appear to point backward, directly toward the Sun. The display peaked at a visual magnitude of -4.9. Observers worldwide immediately began debating whether this display rivaled the famous 2020 Neowise apparition for the title of Comet of the Century. These stunning visual features are beautiful to look at, but they are also a direct, visible physical readout of the extreme violent forces the comet endured during its solar gauntlet. As it leaves, astronomers are analyzing its polarimetric data, measurements of how light waves are oriented after bouncing off the comet's dust. This data proves that the optical properties of dust in the pre-solar nebula were likely uniform. Because this dust has been frozen and isolated since the solar system first formed 4.6 billion years ago, that uniformity provides us with a pristine look at the exact chemical conditions present during that era. With perihelion complete, Tsuchinshan-ATLAS is on its final trajectory. It is rapidly fading into the pitch-black void of deep space, and it will never return. It survived an 80,000-year plunge to give humanity the show of a lifetime. It deposited invaluable data about our origins into our telescopes, and then it returned to the dark forever.